next week. Okay, starting from the next week, the ecology seminar starts. So finally, we are behind the schedule, but next week ecology seminar starts, and it will be pollination network in tropics by Stepan and Necek next week, of course, followed by discussion in KMP. So important parts will be as always. And today, I will start to speak about biodiversity ecosystem function experiments and generally what they say about the result, what the results say about the consequences of a species loss in the real world, and generally what they say about the real world. I will start with picture of nice communities. These are communities, plant communities that are very species rich, and we like them. We like communities that are very species rich, either this or you might be more familiar with tropics. They are really nice. And everybody knows that species are recently lost from the communities. There is decline of species richness generally everywhere. And ecologists for a long time try to show that the species loss is not only from say point of view that we will never be able to recreate species that are lost, but that it might have also some functional consequences. And so loss of species from ecosystems is well-known fact, and I will discuss whether can the loss of species change the ecosystem functioning, can they jeopardize the ecosystem functioning, and can the better functioning of species-rich ecosystems used as conservationist argument. And finally, I have some doubts whether we are really able to demonstrate this with sufficient scientific rigor. Then, what is better functioning? If you have a look, BEF is the acronym that is generally used and is expected that people know what it is. But if you have a look on literature, you will realize that in most cases, functioning is just that they measure standing biomass or productivity and not much more. In the last time, they try to concentrate on some things like ecosystem services, and particularly they have a look very often, or we have a look, I'm partially engaged in this research also, on stability. And you might, why should be the functioning better, of functioning of species-rich communities better? There are two basic mechanisms. First, it is something which is called selection effect or sampling effect, depending on which side of the dichotomy you stay. The people that are promoters of the biodiversity ecosystem functioning, or that say that they are correct way how to do the science, use the selection effect to stress that it is something natural, whereas the people that call this as hidden treatment say about sampling effect, stressing that it is more or less the artifact of the design of the experiment. And then this is something which is definitely considered by everybody, the real biodiversity effect, and it is the complementarity. What is the sampling selection effect? If you have a pool of more species, and just few of them are able to do the job, to be sufficiently productive, to be able to take resources in a good rate and so on. The more species you have, the higher is the probability that the species that is able to do the job will be present. On the other hand, complementarity generally means that two species are able to use resources in different way, and thanks to this, their mixture is more efficient in taking the resources. Similarly, the idea of stability is that if you have many species and one of the species fails, then the other species are able to replace it functionally. This is called the insurance hypothesis generally. And this is behind the original idea of MacArthur And this was the idea that diversity begets stability. You are probably familiar with this formula, but instead of S, you would use H there, and you would call this Shannon index of diversity. Fine, no problem, but you might be surprised that it was introduced to ecology in 1955 by MacArthur, and not as an index of diversity, but as an index of stability, because this time the belief that diversity begets stability was so strong that he doesn't even bother to call this index of diversity, he calls it directly index of stability. Then people believed that there is classical evidence that diversity begets stability because population outbreaks are more common in species poor polar regions than in species-rich tropics. You know, lemmings, you have autumnal moths on the berg, in Abisko, and so on, whereas nothing like this is generally known from tropics. Similarly, they are more common in arable field monocultures in comparison with the classical species-rich communities. Nevertheless, you have always a confounding factor. If the two natural communities differ in their species richness, it must have some cause, and it is usually comparison of tropics and temperate, or tropics and polar, comparison of agricultural artificial communities with the natural communities. On the other hand, you have, for example, if you remember, on the shores of lakes, you have reed belts that are very species poor. You have just reed fragmentous communities and not many other species, and they are usually very, very stable. So the idea was, if you want to disentangle what is effect, what is cause, then do the manipulative experiment, which is a nice idea, which I like. Nevertheless, this led to the development of the whole branch, and these are biodiversity ecosystem functioning, where you artificially create communities of different species richness, and then you follow what it has, what effect has the species richness of the community on its functioning. And as I said, in most cases it is the productivity, primary productivity. Okay, but the problem is how to manipulate, how to put together the individual species to form a communities so that it is not too much artificial, and that it will tell something about the species richness effects in normal nature in the real world. And that it is not simple task is that I will come back to the start of the biodiversity ecosystem functioning experimentation, but the discussion whether they tell something or do not tell anything is pretty vivid even in these times. And this is paper from 2016 by David Wardle. You might have known this name. This is really one of the heavyweight ecologists. On the other hand, on the other side of the spectrum, the proponents are people like David Tillman. So really heavyweights fight. And this was paper which was published by Forum. I would say that those days it is more and more. If you have a look on most of the meta-analysis, everybody says it is clear the biodiversity experiments have clearly demonstrated that higher species richness demonstrates better functioning, and it is more and more difficult to publish the paper. I know about this because despite the really heavy weight of David Wardle, I reviewed this paper for higher ranked journal and was excited. I liked the paper, but finally the paper was rejected there, and he finished in Journal of Vegetation Science, which is not as prominent paper. And of course, immediately there was response of the proponents of the biodiversity ecosystem functioning experiments. And 2 years ago, now this is already 3 times running, so 2019 in ecology, was published a paper, not even wrong, the spurious measurement of biodiversity effects. So the discussion is time from time very, very strict and very strong. And of course, there were again responses. I was engaged in this paper where we were groups of people that are on the skeptical point of view and the proponents. And I must proudly say that they accepted my use of real work, because I was probably the first criticizing this using it doesn't correspond to real work. So people at least accepted that we should have a look on real work. And how everything started. This started with the paper from 1994, which is recently cited something like 1,200 times, so it is highly cited paper, saying that declining biodiversity can alter the performance of ecosystems. This is quite a bold statement, and you would expect something based on a really large data set or something like this. On the other hand, what they have done, they have mesocosm, artificially created mesocosm of different species diversity, and have shown that the more species they had, the higher was the productivity. And then, of course, if they have higher productivity, then the fluxes of gases were also higher, because if you have more plant biomass, you have higher photosynthesis and so on. Moreover, what they have, and this is from the papers that try to criticize, and I know also that it was very difficult to publish this paper, and there were several journals rejected it, but how was the design of the experiment? I would say that it is terrible design. This is something which you could not imagine that you would even ask to be bachelor thesis, because for low diversity, they have Senecio vulgaris and Stellaria media, and then they added various species, and you can see this is what was added by Huston in his criticizing paper, was maximum height. So if they have Stellaria media and Senecio vulgaris, and when they added Chenopodium album to the mixture, the productivity increased. And when they added some other species like Sonchus oleraceus, the productivity increased again, which is, of course, not so surprising. And interestingly, they used even to create nice species-rich communities, some very nasty weeds, but terrible weed. If you are gardening, you probably know Conyza canadensis. It is one of the most nasty weeds that you can imagine. So if you have a look that you start with Stellaria media, and then you add Chenopodium album, the productivity will increase. If you add this will also increase, and you can create nice communities with this nasty American weed. So this was the experimental design that was criticized, and this criticism was accepted, because here clearly species A, it is simplified. So if you add further and further species, you are not able to distinguish the effect of species richness level against the new species that you add. So what is today's considered like a most reasonable approach that you can do? It is important that the species identity or species representation is exactly the same in each species richness level. So you see here each species is in single plot, in 2 richness 2, each species is then added twice, and so on. So the representation of species is exactly the same, in each level you have all the species represented equally. And in this design, there were done one of the largest ecological experiment that you might know. And this is an example of Vienna Experiment, which started early in this century. So it is running already for more than 20 years. And you can see how large the experiment is in comparison with Vienna city. And it is, of course, the diversity gradient is much wider because they started with monocultures and have the largest 32 species, and then they have even 64 species. But it is done in this way generally. And so you see, this is one of the proponents of this. This is Nico Eisenhower, and getting soil samples, and they measured everything, including the fluxes of gases, or including the composition and abundance of insect communities. So they have quite a lot of data, and incredible amount of work was done. Nevertheless, still everything is dependent on the basic idea how the communities are assembled. And this is what I am criticizing. Here is the paper, if you are interested in. Here is the paper that shows what have been done during 15 years. No, they have 20 years. And typical results which are there, typical results show that biomass increases with the number of species sown, and these are either sown or they are sometimes planted, because most of the work have been done. Most of the work had been done in grassland communities. On the other hand, recently, and particularly in tropics, when you have fast-growing trees, something is done also with tree communities, as Vojta noted in his lecture, and then you usually have planted not sown species. And the typical results are here. And again, what is nice, this is the paper. This was large Biodiversity experiment, which started in the previous century. This was published in 1999. Was done in roughly 7 countries within the Europe. And they want to stress the importance. They want to stress the importance of the decreasing diversity of species loss. So they even reverse species richness. So this is 1 species, this is 12 species, and when you go from 12 species to 1 species, the productivity decreases. You might see how nicely are the fitted lines parallel. So it is the common effect for everybody. Apparently, the guys decided to omit the interaction between country and richness from the model. So thanks to this, the lines are parallel. In the next paper, they realized that it was probably not the best idea. So in the next paper, they realized that the interaction is really significant. So they increased the interaction. And here, this is from the paper. Okay, this makes sense. On the other hand, even if you have a look, then if you have a look on the maxima do not change too much, if at all. What is that there are quite many monocultures that push down the 1 species biomass down, and these are the unsuccessful monocultures. Okay, so this is the effect, how it is calculated, because generally what is affected is average. And if you have some nice maxima of successful monocultures, then the unsuccessful monocultures are more numerous and keep it down. Nevertheless, for some reason, David Tillman decided to comment and has written in Science the commentary to this, and decided that you need 16 species per square meter to have the productivity high. And he has written, this is directly from his commentary at the beginning of the Science, and he has taken species area relationship. Everybody is probably familiar with species area relationship, and he estimated that the Z value in C times A on Z is 0.15, which is quite conservative. So he decided, and he says, okay, if you want to have high productivity, on 1 square meter, you need to have 127 species on 1 square kilometer. And this is complete nonsense, and this is how the conservationist argument should not work. because this is definitely not true, and this is simply the main criticism which is there, that if the farmer would like to grow some high productivity monoculture, he will not try all the monocultures that are used in biodiversity experiments, but he will go directly for ryegrass. And if you go for ryegrass, you will have high productivity regardless of the number of other species, because ryegrass is the strongest competitor and will so outcompete anything which would be there. So I would be very careful to use this in this way, the results as a conservationist argument. Simply because in the experiments like this, you average the ryegrass with the monocultures of Aphanes arvensis or of Arabiopsis thaliana, of the species with very small productivity, and then it shows that the productivity of monocultures is low. On the other hand, if you imagine that you have a community and you have soil where is Chenopodium album or ryegrass able to grow, then to keep monoculture of the annual weeds there is complete nonsense, because you would need to weed and weed and weed. By the way, this is for PhD students. Be happy that you are not in the beginning in Vienna, because PhD students have the duty of slavery work by weeding the plots to keep them to be monocultures. I am not sure that they have in Vienna or somewhere Aphanes arvensis or Arabiopsis thaliana, but definitely you have seen that they started with some species with very low productivity. So if you do calculate average of low productivity species and ryegrass, you will get something which is very low. And I said that in most cases, as ecosystem functioning, they have the total productivity. On the other hand, it is not only total productivity, and they have measured quite a lot of ecosystem functions, ecosystem characteristics like nutrient uptake, carbon in soil, or photosynthesis. On the other hand, if you have those, they depend on the total biomass which is there. So they demonstrated that all of these are dependent on species richness. Okay. And when we come to two basic mechanisms, selection and chance effect, and how they function, how they work in this experiment. So this is the effect of what is selection effect, how it works. If you have three monocultures, two of low productivity species and then Chenopodium album, then the two mixtures of low productivity will be very low. One monoculture of Chenopodium might be very high, but finally you will get a relatively low average. On the other hand, if you have mixtures, Chenopodium album naturally will prevail, and due to decreased density, the individuals will be larger, there will be higher establishment, so the mixtures will have a higher biomass than the average of monocultures. And this is called biodiversity effect. So this is what I'm very skeptical about. On the other hand, if it is pure selection effect, the mixtures are never better than is the best of monocultures. So if the mixtures are, on the other hand, if there is real complementarity, so the complementary use of resources, in this case, this is an example of tall tree and low shrub, where shrub is able to use to photosynthesize even in the shade, so to use the light which is not used by the tree canopy, and there is differentiation of rooting depth. Then it might happen that, and it is very probable, that the mixture might have higher productivity or higher function than the best of monocultures. And this is called transgressive overyielding, and transgressive overyielding mixture is better than any of the monocultures. It means then that there is in the play, it is something more than the pure selection effect. And there was strong discussion whether selection effect is something which is real or whether it is just artifact, what Huston calls a hidden treatment in the biodiversity experiments. Nevertheless, there is again problem of realism, as I said. Monocultures of low productivity species in productive environment is something which never happened. So we should say we are doing statistics. And what is statistical universe? If we have random selection of communities, it is each combination is equally likely as any other one. Then we test. And our statistical universe are all the communities which include monocultures of Arabidopsis thaliana into productive environment being as likely as species-rich communities or as monocultures of highly productive species. And it comes to graphical presentation of species. Just years ago, it is more than 20 years, we have done simple experiment in pods just to show how you can manipulate with the data, and these are results of the same data which are shown in several graphical ways. And the first one is how the data are usually presented in all the papers, and it is mean and standard error. It is important. Use standard error because the error bars are then shorter. Then it's you could say it is clear. The results are clear. There is nice decreasing saturating function with increased number of species. If you, however, show the original data, for example, using box and whisker plot, you will see that what is really low in low diversity mixtures are the minima. Some species have very low productivity, but the maxima are generally quite independent. And we have then suggested another, because we have 6 species, and the most productive species was Holcus lanatus, very productive grass. And if you take, and these are crosses, species with mixtures with Holcus lanatus, so generally you have got completely horizontal line. There was no diversity effect. So if the strongest species was present, then there was no biodiversity effect already. And generally, this is what was criticized. This is the naive expectation, and it is naive expectation for the calculation of biodiversity effects. This is from the paper Not Even Wrong. We have tried to show something some years ago, but generally, I will repeat, we have this experimental design, and you should be aware that what is used for the experimental design is shown here. If you have 4 species, then what is used is David replacement series. David replacement series is something what was used in 60s, 70s in agricultural research, of intercropping and so on. And this means that total sowing density, or in the cases of trees, it will be total planting density, is constant. And either all the 100 seeds, say we decided for 100 seeds, or the 100 seeds are single species, or in 2 species mixture, you have 50 and 50 species for the 2 species, or for 4 species, you have 25, 25, 25, 25. And what is expectation? How it is done? The expected yield, if there is no biodiversity effect, no expected yield, if there is no biodiversity effect, is that the productivity will be linearly dependent on the number of species of seeds of the particular species sown. So the productivity should be 4 times lower for the species A here. And this is classical David replacement series. By the way, if you remember, David is quite well-known name. He was agricultural ecologist in Wageningen, if I remember correctly, and he is one of the guys. There are different, what I like to show this also, I'll show it also, the differences about how people estimating the carrying capacity of the Earth for people, how many people is land able to feed. And he has the record, he has the highest one. So he expected that land can support 1,000 of billions of people. So, okay, but he said it is just based if everybody eats just plants, and it is how many plants we are able to grow, and how many people will be able to live based on the agricultural production which we are able to do. But this is just as interesting thing that it is the same, David, at least I hope. And then there are some biodiversity effects, and the basic one is delta Y, difference of yields, and this is generally difference of real yield against the expectation based on the linear relationship which is there. And then there is the partitioning of this, and this is based on the comparison of the yield in the community, in the mixture with this monoculture yield. And if the species, and this is why you have here covariance, if the relative yield, so it is how much more species produces in comparison with expectation. If the species that produce more than expected on the linear expectation, it is positively correlated with its monoculture yield, it is selection. On the other hand, if all the species have higher relative yield than expected, then it must be complementarity, because if it is selection effect, some species might have more, some species might have less. So this is how it is calculated, and it is important if you read the meta-analysis, and they say that the complementarity was demonstrated in such a high percent of cases. This was nothing that they would really demonstrate that the resources are used in complementary way. This is just that Hector and Loro partitioning gave positive complementarity. So one should be careful, because this usually might work, but not always. Okay, and then there is something like law of constant final yield, and this shows that with increasing sowing density, the production of total yield increases, but not linearly. Whereas the expectation is that there is linear function. And if you use linear function, then I have here, imagine that you have sunflowers and daisies. You have sunflowers and daisies, and here, if you have sowing density 50 and 50 for monocultures, you will have daisies, nothing, and sunflowers will have 1 kilogram of biomass per square meter, which is possible. If you decrease the sowing density in the mixture to 25, then the productivity of sunflowers, you can imagine that if you have 50 sunflowers per square meter, then it is pretty dense. So if you have 25, still the productivity will be nearly the same. On the other hand, the daisies will be outcompeted, but there will be something very small. On the other hand, the expectation here is that instead of 1,000, you will reduce by 50%, so it will be 50. So expected total yield is 525, whereas the production of the sunflowers only is much higher. And it is called still, if you calculate biodiversity effect, so you will still have strong biodiversity effect. Interestingly, if you would use, okay, to be honest, if you calculate then the hectare partitioning, it will show that everything is sampling effect. But still, if you report, there is net biodiversity effect of this. Interestingly, if you instead of daisies would use sawdust and you have 0,0, then still you will have a biodiversity effect. So this is something which is quite artificial and which I do not like too much. Random species composition of communities look correct from statistical point of view, but the point of view of species loss simulates the simulation when species are lost from communities at random. And this is something which is really weird, because in the real world, we have the situation that environment and species pool generally determine species composition, and this determines productivity. Whereas in biodiversity experiment, we have manipulated species composition to change the richness and look on its effect on productivity. And empirical results, this is important, empirical results with productivity in the natural communities being the predictor look pretty different, because this is the classical humpback model which is there, and usually it is said that the communities on the very unproductive part of the gradient are species poor. Simply, if you have pure sand, very few species are able to grow there. Then you have some maximum, and on highly productive side of the gradient, usually species are also poor, and this is mostly because it is expected, because a competitive exclusion at highly productive communities, the richness declines. This is what we have done, and we have shown with Aleš listener, we have done similar sampling and have shown that even the unimodal is not so general as it is, and it is well known, and it depends on spatial scale, it is on grain, how large quadrats you have, and the extent, so how long gradient you have, and also it depends on what productivity. You might notice that here you have all productivity from biomass to biomass and later up to concentration of phosphorus and potassium. So very different, and the results differ very much on how you measure the productivity. Nevertheless, this is my Ohrazení experiment showing that if you do not fertilize, the species richness is very high. You have here up to 40 species per square meter, whereas once you start to fertilize, the species richness goes down pretty fast. So generally, if you have productivity as the characteristic of environment, then if you have productivity as characteristic of our environment, generally the case that you would find positive relationship with species richness is generally rare. This is because species richness is limited by species pool size, environmental filter, and biotic filter. And generally in Europe, and particularly in Central Europe, if you have species pool communities, generally species pool limitation is in islands, but that you would have species pool limitation, the species would not be able within Czech Republic to travel somewhere is unlikely. Harsh environment, okay, it happens in artificially created, if you have toxic depositions or something like this, but most of normal species pool communities are due to eutrophisation, where the species are outcompeted. And in biodiversity experiment, you manipulate just species pool. So what results of biodiversity experiments corresponds to is the case of communities that are species poor due to species pool limitation. And if you have a look which species are lost from communities, this is if you have a look at this category endangerment category of species, and if you have a look Ellenberg values, is something, Lemberg values is something which shows you whether the communities are confined to species, to nutrient-rich and nutrient-poor environment. And species that are lost are the species that are lost are the species that are confined to poor environment. So definitely the loss of species, not a random process. So you can have either statistically correct random selection of species that are lost and then it doesn't correspond to reality, or you can try to have something which tries to mimic which species are likely to be lost in the communities. Generally, the species that were lost in my experiments in Horazeni are 10 centimeter tall sage or this hemiparasite. These are species that are nice. I love to have them. I like to have them, but if they are lost, it doesn't affect the productivity or gas exchange and things like this of the community at all. On the other hand, and this should be stressed, that the rare species might be very important for hydrotrophic levels. We have demonstrated with Karel Spitzer years ago on the basis of his data from light traps in Chernish, that species of plants that have extremely low gallium palustre have on average biomass of 0.3 grams per square meter and still was able to support the large population of monophagous insects in the community. So rather than diversity begets stability or diversity begets functioning, I would say that diversity begets diversity, which means diversity of plants begets a diversity of hydrotrophic levels, and this works. And finally, we try to do, this will be the last thing, that we have tried to do a realistic scenario with species-rich communities in Ohrazeni when we created, or Aleš created, I didn't work with my hand on this, but Aleš has done this, and this was, he created richness gradient on 1, 3, 6, and 12 species, an intact community in the species-rich community in Ohrazeni. And he followed this already for 5 years. And here are the relationship with effective number of species, which is anti-logarithm of Shannon. So in different years, the relationship was either slightly positive or slightly negative. And as a matter of fact, one of the most productive plots was monoculture of Molinia. And of all the plots, this one was the community with highest biomass. Similarly, if he compared various treatments, generally over the years, average over the years, there were no effect of diversity at all. And even monocultures were able to reach the productivity of the whole community. So one should be aware that the diversity gradient has an effect which depends on how the diversity gradient was formed. So to conclude, biodiversity experiments still reveal many mechanisms behind functioning of ecological communities. I have not spoken about the successes. I have tried to show more the caveats that one should take when he looks on and what are the problems with the interpretation and with the real work. On the other hand, when you have a look on mechanisms, then the people in Vienna have done incredible amount of work, including the soil effects and including the effects on and off the hydrotrophic levels. But their relationships to species source in real communities is very uncertain, and I would be definitely very, very careful, and I would never use their results as an argument for conservation. But I like species-rich communities, and I thank you for attention.
Thank you. So questions, comments, please, here.
Yeah.
I like how you made this very big historical background of the history of the biodiversity experiment. And I wonder if this disconnect that you are raising between the conservation applications and the experiments is because there is this mix between, like, everyone is looking just at productivity or biomass, which is relevant for agriculture and applications of this idea to agricultural practices. But when we look at conservation, the functions that we are interested in are completely different, and it's much more connected to interactions and by diversity begets diversity, then diversity begets stability or whatever else.
Okay.
What do you think, like, why do we still look only at biomass if for conservation other things are more important?
Okay, for conservation, my arguments is that okay, it is. I don't know why people do it, but if you have a look on literature, they always cite how important is the richness for functioning, and then you see. They use the term functioning, which sounds much better than productivity itself. But what they measure is very often productivity or something. If you have the total secondary production, total biomass of insects, of course, the more plant biomass, the more insect biomass. What I see as interesting is really the pollination network and things like this, which are time from time done. There are results like this. But still, again, if you have a look on what is shown for the first 3 plantations. Again, the first thing that they report is the productivity. On the other hand, from conservation point of view, I try to argue that it is important to stress that biodiversity has its value by itself, and you don't need to justify biodiversity by high productivity, because it doesn't work in my view. Because I have there, because if you take this as argument, then it shows that, and they have used invasive species. And if you have a look on invasive species gain, it is increasing species pool. And if you have a look, then the growth of impatiens glandulifera have nice high productivity. Should we be happy that we have belts of high productivity around the rivers of impatiens glandulifera? I would say no, but it is typical selection effect, because you increase species pool and one species prevailed, and the biomass is there higher than used to be before, because it outcompeted other species. So yeah, on the other hand, definitely biodiversity begets biodiversity. So diversity of primary producers results in higher diversity of herbivores. So this is what should be stressed. And there are some cases where it might work. There are some cases that it might work. And this is, for example, if I would decide to sow mixtures of species on the highway verges, then it is really the insurance effect. If I sow more species, I am pretty sure that at least some of them will establish and will work to have green verges instead of flowing soil to the highway. So it works sometimes, yeah. Okay, I wanted to bring, and if people are interested, the paper where we tried in this progress in ecological research, we tried to show where it has some application and where it has not. And we said that with this agriculture, it is very uncertain. Yeah.
Yeah, thank you very much for the nice presentation. Suspa, from ornithological point of view, and maybe it's a simple question for botanists. But I would like to return to the humpback shape, let's say, pattern in productivity affecting the species composition and diversity. Do we have some average values of nutrients, everything what really supports the highest diversity communities, as is, for example, meadows in Biela Karpaty, and whether it works the same across several habitats, so whether you can say that the same amount of nutrients would promote, let's say, some meadow communities here at Hrabenské rybníky, or do we need really different, let's say, the best conditions for best highest diversity scenarios? And is my perception correct that the whole republic is, let's say, flooded with nutrients, and that many of those localities are above the suitable threshold for the highest diversity of species there?
Definitely. First, the last sentence was exactly true. The whole, the largest problem of the species loss in meadow communities is eutrophication. With this increase of nutrients, the productivity is much higher. This is why I said that as conservationists, we try to persuade farmers for years to keep the productivity of species-rich communities low, and then they will come and tell them, and thanks to the high species richness, you will have higher productivity. This is nonsense. On the other hand, it doesn't exist. The optimum value doesn't exist because they selected here the humpback shape. On the other hand, if we were, and these are the results with Aleš, for example, here you have the red one is České Budějovice, the green one is Železné Hory. So within and here you have above ground biomass. And for us, the above ground, the productivity was declining, the species richness was declining with productivity from 100 grams per square meter. So it is rather low productivity, so really the lowest productivity. On the other hand, grime had here maximum productivity at 600. No, grime was where is grime? Almufti, yeah, this is British. Almufti and grime, and here is about 100, but here is plant biomass and litter. This is it doesn't exist and depends on the management. So high productivity of the White Carpathian meadows is reasonably low productivity, but not extremely low. But reasonably low productivity and regular mowing. So it depends. The species are lost from our meadows for eutrophication and fertilization and for abandonment. Sometimes it is important to avoid competitive exclusion, to keep a reasonable amount of nutrients, and at the same time to repeat mowing. Once you lost mowing, then even low productivity will result in decline.
All right, thank you.
Okay, I will like to ask if there is someone with a question online. People online, do you have some questions? Seems that no one is reacting, so Matthias, please.
Yeah, I also wanted to ask on the subject of productivity, since I know you are also very much involved in the topic of functional diversity. Are you aware that there is so far a general trend of connection between functional diversity and productivity?
Okay, they are, and again, the relationships are in various directions. If you have a look on ecosystem functioning, diversity, on the experimental part of the work, when you manipulate, then there are trends with functional diversity and with phylogenetic diversity. This was a paper which shows in some meta-analysis that phylogenetic diversity is better predictor than functional diversity. So they are, but all of them are still. Once you start to work with functional diversity, you do not see that everything is dependent on the number of species on the selection effect. And once you have functional diversity, you stop to have a look how much it is the sampling effect and how much it is complementarity. But generally everything, what is the theory behind? The theory behind is that here, this is generally the functional diversity. So this is generally the functional diversity, and it is question how much the functional diversity and what is the function of phylogenetic diversity in these cases. Definitely the works, we had one experiment in Benešov when we had the constant number of species, which was 6, and orthogonal gradients of functional and phylogenetic diversity, because you are able to create in nature functional and phylogenetic diversity, because traits are conservative, will be positively correlated, and we created there gradients of functional and phylogenetic diversity that are close to orthogonal, and the effects are much less pronounced than when you have many species, because you do not have there such a strong selection effect.
Thank you. No more questions here. I don't see anyone reacting online. There are still around 20 people there, but they will have questions anyway. So thank you very much for wonderful talk.
Thank you for invitation, and do not forget next week to come for ecology seminar in KMP. Yeah.
Thanks.
Thanks.